Okay, 1.4 functions. Okay, we need to remember what a function is. You don't need all those words. Anything in a blue box are the words from the book. And I'm going to tell you right now, you don't want all those words. You want to find your own words, okay? So I'm going to read them to you, and we're going to talk about what it is. Does that make sense what I'm saying to you? Okay, a function f for a set A to set B is the relation that assigns each element in X each element X in A to exactly one element in the set B. So basically, a function is every X has exactly one what? Y. So a function, every X is assigned to exactly one Y. So the reason why I have that there is because you guys need to start learning how to read these things and understand what they're saying. I will tell you that there's some times that I assign you just to read and take your own notes, and then we'll go over them the next day so you can start learning how to do that. Okay? So the domain are the X values or inputs, right? Inputs. What other word for domain?
Not function.
Doesn't make sense. What about independence? Independent variable? Okay. Now, in science, you talk about your independent variable, and it's usually time, right? And things like that. So, X values are inputs or independence, and the domain, the range are the what values?
Y values.
The Y values. Or the outputs. Or the dependence. You've heard all these words before, yes?
Yes.
We've talked about them last year extensively. We talked about it a lot last year, and we're going to keep talking about it, and it doesn't ever go away. So here's just a picture. We have time as my independent and temperature as my dependent. Is this a function or just a relation? Every X has exactly one Y.
No.
Does every X go to one Y?
Yes.
Yes.
Can they have the same?
They can have the same Y, but what if I did this?
No.
No, because 5 has two Y's. Basically, it's a function if I ask you what the answer is, and you can say the answer is 6. Does that make sense? If you go, well, it's 6 and 3, then you don't have a function. To determine whether or not a relation is a function, you must decide, and down here it just says exactly what we said up top. Each X element is matched with exactly how many Y's? 1. Okay? So there's a lot of writing on these slides. You do not need every word. If you were going to write every word, then you need to go back and watch them every night at home. Okay? And if you want every word, I would advise you to watch the video from last year before you come in this year and have all your notes taken. Does that make sense what I'm saying? Because we will never have time in class to get through notes if I wait for you to write every word. Okay, good? Mm-hmm. Okay, 4 ways to represent a function. You know these, they're just listed. I can write a sentence, right? Verbally, numerically, I can do a table or ordered pairs. Graphically, obviously a graph, or algebraically, which is an equation. We usually see things in equation form, correct?
Yeah.
So We have the first one. These are just examples. You don't really need them. You might want to write the 4 ways verbally, numerically, graphically, and algebraically, but that's it. So the input value X is the number of representatives of a state. The output is the number of, the output value Y is the number of senators. That is verbally. We have an XY table or an input-output table, which you guys don't like to think that exists, but it does. We have a graph, and then Y equals X squared plus 4 is an equation. So those are the 4 ways, verbally, numerically, graphically, and algebraically, that you can represent a function. When you first saw functions, they were these 2 ways, graphically and a table, weren't they? Way back many years ago, right? Now when you see them, they're usually numerically or verbally, where you have to write your own. Am I good?
Almost. Okay.
Good? Everyone? Okay. Testing is something as a function. So we need to solve these and see how many values are we going to get an answer. So the best way to do this is do Y equals, correct? Solve it for Y. So I have X squared plus Y equals 1. How would you solve that for Y?
You move the X over.
Subtract the X squared over. So I have Y equals 1 minus X squared. If I plugged in any X, would I get one answer? Yes. So this is a function. Now, I did not prove it. I used our number sense, what we know about a quadratic equation, correct? Should you all in your head know that this is what this graph looks like? Yes. We did that enough last year. You have a negative X squared. You know it looks like that. I didn't put it anywhere. It actually went up 1, didn't it?
Yeah.
So if I were to draw it like this, this would be a 1. Right? So that's what it looks like. You're seeing it in your head. So the next one, negative X plus Y squared equals 1. So we should also solve it for Y, correct? How would you do that?
Add the X over.
Add the X. So I have Y squared equals 1 plus X. And now what? Take the square root. But when I take the square root, how many answers? Plus or minus. So every X I put in there, I would have how many solutions?
2.
I would have 2. I would have the positive and the negative. So is that a function? No. And you should say why. Okay? Not a function. Because every X value has 2 Y values. And I want that. Not a function or no is not a complete answer. I want to know why. And every answer is going to be every X value has, it could be more than 1. Or this one we know there's exactly 2 because it's plus and minus, correct? So when it is not a function, I want you to explain to me why. So I want to see your work, any work you used, and why. Now, you don't have to tell me, bless you, why it's a function. That would get really old, would it not? Am I good?
Yeah.
Okay, domain and range. Oh, sorry, domain. So domain, we want to think about the excluded values in a function. So this is a fraction. What is the one thing we cannot divide by?
X squared.
What is the one number you cannot divide by? 0. Okay, so domain excludes values that result in a division by 0. because it is a fraction. Yes? Most functions have a domain of all real numbers. I'm telling you that right now. But once we put them in an application problem, we have situational domains. But anytime you have a rational, you're going to think after this next month that every domain is limited because you're going to deal with so many limited domains. But that's not actually what happens. So if I need to know what values make my denominator 0, I need to set my denominator equal to what? 0. You did this on your review sheet, correct?
Yeah.
Yes. So I have x squared minus 4 equals 0. There's 2 ways I could solve that. Somebody give me one.
Add the 4 over.
We could factor. Here. So we could factor x minus 2, not 4, I was going to put 4, and x plus 2 equals 0. And Savannah said you could add 4 over. You could.
And then take the
Okay. And then take the square root of both sides. And on the left, you're going to x equals plus or minus 2. Correct? And on the right, what are you going to get? X equals
x equals -2 and +2.
plus or minus 2. Now, I'm going to tell you on the right, people tend to forget the positive and negative. How many times do I say, what's the answer? And you say 2. And I'm like, nope. Right? So, you need to start remembering that. But if you factor, are you always going to see the positive and negative 2 there? Yes. Okay, so we cannot have positive or negative 2 in our domain. Correct? So, right here, it says set notation. I should have moved my work somewhere else. So remember, set notation is the curly bracket. X such that x cannot equal what?
0.
Nope, it can't equal 0. Like the solution to the denominator can't equal 0. What's going to make it 0? We just figured that out.
Plus or minus 2.
Plus or minus 2. Okay. Now, this is the way I am going to write domain. Because we do lots with intervals in here, I don't want to deal with having an interval domain and an interval that I'm testing. My brain does not like to deal with it. I don't care how you write intervals, but you better do it right when it's for domain. I do care, I don't care which one you use, interval or set. But if you use interval, you better do it right. Okay, so the smallest is -2, the biggest is 2, yes? Is -2 included?
No.
Yes, it can be -2. Like it can't be -2. Does that make sense? Wait, you are right. I'm wrong. -2, it can't be -2, so I can't include it, so I have to put a parenthesis. Oh, shoot. I'm getting ahead of myself. Here's the number line, yes?
No.
Okay, what's over here?
Negative infinity.
Negative infinity. What's over here?
Positive.
Positive infinity. So we've got negative infinity to -2, right? And we've got
2 to
We got 2.
infinity.
Nope, we got
-2 to
-2 to 2. What do we put in between these two?
Brackets.
A union. Remember they doing that as last year? Okay, -2 to 2. And then we've got what?
2 to
So I have to put another union and 2
positive.
to positive infinity. And all those are parentheses because the 2's and the 2 -2 are included in, obviously. Now, which one of those is more efficient? The first one. Okay. I despise this notation because of these things. Because you know what? This could be plus or minus 2 and plus or minus 4 and 6.
So we only have to do one of them?
You only have to do one of them, but you have to be able to read both.
Okay.
Does that make sense? So when you see interval notation, you have to know what it means, but you don't have to use it to tell me.
Okay.
Okay? Am I good? Okay, so a square root. A square root's one of those things. If I gave you quadratic, the domain all day would be all real numbers, correct? It's quadratic. Rational functions, fractions, and square roots have issues, don't they? Yes? What can't we take the even, what word did I just stress? Even root of. What kind of a number can I not take an even root of?
A negative.
A negative. Can I take the odd root of a negative number? Yes, because a negative times a negative times a negative is still a negative. But can you take a negative times a negative and get a positive?
No.
No. Remember when we had those negative even roots, we have imaginary numbers? Yeah. Okay, so the domain of a even root, or we're going to talk about square root right now, is the numbers that make this negative. So what is the first non-negative number?
1, 0.
0. So I would set the radicand equal to 0, just the same as I would a rational function. But this one's pretty easy. The radicand, the stuff under the radical, is what? What is it? X. So what makes x 0? 0. Yes?
Yeah.
The only thing that would make x 0 would be 0. If I had this, I would set x minus 4 equals 0. Get where I'm going? Okay, so I have 0. Now, we need to decide if we're going to have bigger x's to have positive numbers or smaller x's to have positive numbers. I want positive numbers. Are negative numbers going to give me positive numbers in this situation?
No.
No. So I want x such that x is greater than, can it be equal to 0? Can I take the square root of 0? Yeah, what is it? What's the square root of 0? 0. It's not negative, is it? So x is greater than or equal to 0. So in interval notation, where do I start?
Negative.
Negative infinity to where?
0.
0. Then union 0 to, actually no. I said that wrong. Sorry. We don't have a compound inequality, do we? We just need everything bigger than 0, yes? Okay, so we start with 0.
To positive infinity.
And why is it a bracket? Yes, it is to positive.
Because there's no other numbers.
No, can it include 0?
Yeah.
Yes, so it's a bracket. In general, the domain of functions exclude values. This is how you figure out the domain of functions. The domain of the function excludes values that would cause division by 0 or that would result in an even root of a negative number. Now, even root of a negative number. So 2, 4, 6, those. Odd roots, it doesn't matter. You can put everything in the world in them, and so it's all real numbers. But it really depends what the radicand is. What if I had the square root of negative x? It wouldn't be numbers greater than 0. It'd be numbers what? Less than 0. Because two negatives make a positive. So on a radical, once you find that threshold, in this case it was 0, you have to decide whether those numbers are going to be bigger or smaller. And you know the easiest way to do that? Test a number. Test something bigger, test something smaller. And not barely bigger, a bunch bigger. Do you have to write it out?
Yeah.
No. You don't have to write out your test. You just have to use your brain to do it. If you want to write it out, you're more than welcome to.
Some people don't have bright brains.
Well, then write it out. Okay, are we done?
Yes.
Okay, find the domain of the first one. It's just a list of numbers, guys. What are the x values? Least to greatest. -3.
-1, 0, 2, and 4.
That's just a list because they gave me a list, correct? Okay, what's the range?
0, 4, 2, 2,
Okay, order. Least to greatest. -1,
-1, 0, 2, 4.
2, 4. And why don't we say 2 twice?
Because
Because it's the
there's
same number.
It's the same number. We don't have to say it twice. Now, domain went right down the line because we should line up things greatest to least to greatest, yes?
Yeah.
Is range going to do that? No. They're not going to pair up. So we put them least to greatest, but did -3 go with -1? No. So do not, this is not a table, they're not paired up. Okay? So, how are you going to find the domain on B? 1 over x plus 5.
Why don't we do what we did before, where we just did x plus 5 and then set it to 0?
Yep. You set it equal to 0. X plus 5 equals 0, so what can't x be?
-5.
Can't be -5. So x such that, do we want both? Do you guys want me to do interval notation too?
No.
No.
Okay.
X.
Okay, so now h of x equals the square root of x minus 3x. 4 minus 3x. I said x minus 3x, didn't I?
Mm-hmm.
Okay. What can't I take the even root of? What kind of a number?
Odd.
Negative. You're thinking odd root. Okay, I can't take the even root of a negative number. So I have to set my radicand. What is the radicand?
4 minus 3.
The stuff underneath, right? Equal to what? What is the first? Yep.
0.
Both of them you set equal to 0, right? So if I set this equal to 0, hopefully you would subtract the 4 and divide by -3. Yes? So x would equal 4/3. Actually, and I shouldn't put equal. Now, is my x going to be bigger than 4/3 or less than 4/3? Okay, 4/3 is a fraction, yes?
Mm-hmm.
You know it's 1 and 1/3, right? You don't have to put a fraction in. What's bigger than 1 and 1/3? Give me a number. 2. Let's give me a bigger number. 4. 4, 5. Okay. So we're going to use 5 and we're going to use -5. Okay? So if I plug -5 in here, I have a negative times a negative, which is a
Positive.
plus a positive is always going to be a what?
Positive.
So it's going to be positive over here. Yes? If I plug in 5, I'm going to get a positive times a negative and get a
Negative.
negative. And -15 is bigger than 4, so it's going to be a
Negative.
negative. So is it going to be, is x going to be less than 4/3 or bigger than 4/3? Less. Can it be equal to?
Yes.
Yes. So right here, do you see how we just went through that? X is less than equal to 4/3.
I did not get that.
Yeah, that kind of confused me.
Why?
Wait, did you just plug?
I just plugged in -5 and 5 to check whether I got a positive answer or a negative answer. Because I can't have negative answers. That's all I did. A number bigger and smaller than what makes it 0. Doesn't matter. I could put 10 and -10. I could have put 10 and 5. Well, negative 5 and positive 10. It doesn't matter. You pick two random numbers bigger than what you got where it equals 0 and smaller. That's it. Okay, volume of a sphere. Okay, this is situational, guys. What is volume?
Length times width times height.
When someone's hair.
That's
is
of a
really
of a rectangular prism, but what is volume? Like, what is it?
Like all the space it takes up.
Right, oh, the space inside, yes? So it's the space inside. So space, can space be negative? No. Can space be 0? No. So space can't, like space inside, if it is a sphere, cannot be 0, correct? So we need to find out, like, what would make this 0. Well, I'm pretty sure the only thing that would make 4/3 pi r cubed 0 would be what?
To multiply by 0.
Be 0. Yes? 0 would be the only thing that would make that 0. Correct? Now, we don't want negative numbers. And if I put a negative number in there and cube it, I still get a what kind of a number?
Negative.
Negative number. So we don't want 0, and we don't want any negatives, so x has to be where? Bigger than what? 0. Can it equal 0? No. So this one, I should have put, we always should label D. Sorry, guys. So the domain is x such that x is greater than 0. Oh, and these aren't x's. These are what?
These.
Nope. What? R's. R's. For radius, right? Okay, so when it's situational, like C and D, did we have to do some conceptual thinking about what we know about the problem? Yes. Okay, did we have to do some like plugging in to think about it? Yes. That is our number sense, and we've been working on that for 2 years to get us to this point, so we don't have to write every single thing down. Okay? Tell me when I'm good. Good? Ainsley, good?
Yeah, I'm just writing.
Okay. Okay, function notation is a function. That's it. X is your input? Yes? What does f of x mean? Y. Now, the nice thing about function notation, guys, is if it has f of x or g of x or h of t or whatever, it's already telling me it's a function. So if it tells me it's a function, that means for every x, there's exactly how many y's? 1. There's things we already know about this, okay? It passes the vertical line test. Remember doing the lines? And if it passed, we know that it passes a vertical line test. There are things we know about a function, and it's absolutely great, okay? So function notation is an f of x, a g of x, an h of t, an l of k, whatever. It's the function name of the independent variable. F is the function name, x is the independent variable in that thing. If I had w of s, what's the function name?
S.
What the function name is w. This is the name. What is the independent variable?
S.
Okay? The name comes first, the independent variable comes second. Okay? That we'd say the function of the width is dependent on the side or some stupid thing, but width and side would be the same. But it's okay. I don't know what W and S would stand for. But can they be any variables we want them to be? They usually are f of x. They use g of x a lot. You'll see h, l, k. But other than that, they mean something. So, am I good? Okay, find each. So this says g of x equals negative x squared plus 4x plus 1. The first one says g of 2. So g of 2. What did x turn into? 2. So what do all your x's have to turn into?
2.
2's. So I have negative 2 squared plus 4 times 2 plus 1. Use your parentheses. If you do not, I'm going to guarantee half the time you'll mix up your negatives. Use them. Because this isn't negative 2 squared, is it? It is 2 squared times negative 1. Without those parentheses, you tell me the answer is 4. The answer isn't 4, it's what?
Negative 4.
Negative 4. So I have negative 4 plus 8 plus 1. So what? G of
5.
2 equals 5. I expect you to be working your problems down. I've been working on that for 2 years, right? Work your problems down. If you line up your work, look at how nice that is. Everyone knows what's going on. Okay, now g of x is g of what?
T.
T. So what do the x's become? T. It doesn't matter what I put in there. You get me?
Yeah.
So it's going to be negative t squared plus 4t plus 1. I don't have to have a number answer, do I?
Nope.
Okay. Now what is it going to turn into?
X plus 2.
X plus 2. Every single time I see an x, it's going to turn into x plus 2. So it's going to be negative, parenthesis, x plus 2
Squared.
squared, quantity squared, plus 4 times x plus 2 plus 1. Now, here is your trick question, because I gave it to you on all your prerequisites. What does this mean right here?
That times that.
That times that. Foil it. Yes?
Yes.
Yeah.
Foil it. Give me an answer. Remember the negatives out there, so you want to parenthesis again. When you foiled that, did you get x squared plus 4x plus 4?
Yes.
Okay. And then what am I going to do with the next 4? Distribute. And lastly, I have to do what? Well, not lastly. Before I combine like terms,
Distribute your negative.
I have to distribute my negative. So I'm going to have negative x squared minus 4x minus 4. And I stop here because I don't want to rewrite the whole thing. You're lucky you're even getting that. On my paper, I'd go negative, 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 and I would combine them. I don't care how you're showing me work. Show me work. Got it?
Mm-hmm.
Okay, so I'm going to have, it looks like
Negative x squared plus 5.
negative x squared. The negative 4, negative, those go. And then 9 minus 4 is 5. Okay, so we can put numerical values, we can put variables, and we can actually, this is a function on its own, isn't it? So we can put a function in a function. Am I good?
Yeah.
Okay, we're done for today.